Thank you for downloading this podcast from Talk Radio 702 and 567 Cape Talk. For more podcasts and more information on your number one news and talk station, please visit 702.co.za or capetalk.co.za.
Your family, your community, your country, your responsibility. Be the best citizen you can be. Find the Bill of Rights on leadersa.co.za.
Talk Radio 702 and 567 Cape Talk, The Naked Scientist.
Chris, good morning.
Hello.
And how are the Olympics been? Great. The UK is doing really, really well. Great Britain.
Yeah, they are doing very well, aren't they? It's amazing. Not just the gold medal for the coldest and wettest Olympics. In fact, the sun is shining today, which is a difference. No, brilliantly. Depends how you tot the medals up. The Americans are cheating because they're using a different way of counting medals. They don't count gold, they count everything. Which conveniently puts them one step up the ladder above us. But no, we're doing very well. Our guys are brilliantly performing this year, and it's really compelling viewing, isn't it? You sort of flip the telly on and then you can't tear yourself away. I was likening it to there's a brand of biscuits, and they're actually sold as sort of low-calorie diet biscuits, but they're very Moorish, and you open the packet and you have one, you think, well, I'll just have one more, and just one more, works. And then you eat the whole packet, you know the score. Well, the Olympics is a bit like that, isn't it? When you start watching, you can't stop.
I said earlier, I have a hangover. These late nights are really, really killing me.
Yes. Yeah, because you just say, I'll just watch this bit. I'll just watch the boxing, and I'll just this little bit of highlights on the hockey. Oh my God, it's 1 o'clock in the morning again.
Tired every morning. So, Chris, I see that Curiosity did not kill the cat after all. It sent him to Mars.
No, isn't this an amazing story?
Oh, yes.
So, in fact, on our Naked Scientists programme, which goes out on a Sunday, last week, we actually had the guys from NASA, Mission Control, on the programme. And what I'll do at the end of your show, Reedy, is I will tweet a link. So if anyone wants to hear the interview we did with some of those people from Mission Control all about Curiosity, it'll give them a little bit more detail, and they can tell it a lot better than I can. But I'll give the link out. So if you follow at Naked Scientists, I'll put that link so people can catch up with the details. But this is an amazing mission. It is a rover mission to Mars. In other words, rather than just putting a satellite in orbit or dropping a probe down in one place on the surface of Mars, this is actually a mission to put something which is the size of a small car down on the surface of Mars. The rover, which is part of a mission called the Mars Science Laboratory, the rover itself is called Curiosity, hence your opening gambit. This weighs just shy of 900 kilos. So it's both car-sized and also it's car weight. In fact, David Blake, who's one of the people who's built one of the modules on that rover, he actually said he stood next to it and it towers over him. Wow. And to get that thing down, it's not trivial to land something that large on a planet millions of miles away. So what they had to do was to launch last November, fly to Mars, which took them 8 months or so. And then when they went into orbit around Mars, they deploy the lander. And it goes in initially at a fairly shallow angle with a sort of heat shield underneath, which acts a bit like a wing. So it basically slows the craft down a bit, but also can steer the craft. And it has weights that it can throw off the side at various points. And this can steer the trajectory of the lander coming in. And what they were aiming for was the Gale crater. And this is a massive impact crater on the surface of Mars. And in that impact crater, there is an enormous mountain of sediment. And this has actually been formed by the crater forming, then water washing stuff into the crater to fill it up over billions of years. And then subsequent, probably wind erosion, has scoured out the material, and it's scoured it out vertically. So what you've got is a timeline spanning about 4 billion years of material in this crater. So what they're trying to do is to land Curiosity, and this is obviously Sunday night last week they were saying this, they're going to try and land in this crater, because then they just drive up to this mountain that's inside the crater, and by ascending the mountain slowly, you've basically got 4 billion years of Martian history available to you, easily accessible. Well, they did it. So as the craft came in, it slowed itself down with this wing. Then it deployed a supersonic parachute, because there is some atmosphere on Mars, a very thin one. This slowed it down even further. And then when it got too close to the surface, it fires these retro rocket boosters, which basically start slowing down the craft and eventually make it hover about 20 metres from the surface of the planet. And then it winches down the rover on cables. Once it feels the rover touch down, it ditches the lander craft, and the rover drives off, and off it goes. And there are some beautiful pictures on the internet of all the people at Mission Control getting the signal back, going, yeah, we've done it. And Curiosity is communicating with the satellites, and the satellites are beaming the data back to Earth, and then the satellites in California, who are having to live a Martian day. This is the amazing thing, because the mission is costing about 10 million rand a day to be there. They can't go to bed, so they have to stay up, and they have to have their body clock set to the Mars body clock, so they're in sync with all the satellites, so they can control the mission and decide what they want the rover to do and that kind of thing. And the mission is starting. So it's an amazing achievement.
It's fantastic. I mean, it's not only dazzled scientists everywhere, but people all over the world. It's absolutely fantastic. And I know we'll get a lot of questions around it. So our lines are open for you on 021 446 0567, 011 883 0702. We're taking your SMSs as well on 31702 and 31567. Let's go to Days. Days in Harties. Good morning.
Hello, Rudy, and good morning to you, Chris. Chris, let's go from outer space to inner space. The thought processes and various components of the body are joined by a very intricate network of electronic impulses. Where do these electronic impulses get generated? How does the body generate electricity?
Yes, good morning. And that's a very nice question. So effectively your brain contains about 100 billion nerve cells, 10 to the 9, and those cells make thousands of connections to each other and establish networks, and they send electrical signals around those networks. That's how we learn things, see things, remember things. But one of the other important jobs is that nerves flow out of the brain, down the spinal cord, and then out of the spinal cord to target effectors, and these are muscles to make us move, and they also can include glands to make things get secreted. How do those electrical signals get generated in those networks of nerve cells? Well, they actually use a very clever trick. The nerve cell is like a thin cylinder with an interior, and then around the cylinder is the nerve cell membrane, and the membrane is a fatty material. It's phospholipids, and then outside the membrane is the outside environment. And in that membrane are some special pumps called sodium-potassium pumps. And what they do is use energy, called ATP, and they push sodium out of the cell, and they pull potassium into the cell. And they push 3 sodiums out for every 2 potassiums they pull in. And because both sodium and potassium have got a +1 charge, if you push 3 pluses out and you pull only 2 pluses in, over time, the inside of a cell becomes minus compared with the outside, and this creates something known as a membrane potential. And so now what the cells do to create an impulse that travels along is they have little pores in the membrane which can be triggered off, and they can be triggered in a sensory nerve cell, for instance, by you stimulating the nerve or bending the nerve. In a motor nerve, they can be triggered by other inputs coming into the cell and telling it to start firing, and then the membrane changing its voltage a little bit. These pores can open, and they allow a burst of sodium to come from outside the cell into the cell, so you have a little injection of plus inside the cell. This changes the membrane potential, that voltage, very slightly. The membrane senses that change in voltage, and that triggers other pores next door to also then change their activity and let some sodium in, and this acts as a cascade going all the way like a domino effect down the nerve cell, and it can do it very quickly. And if the cells have something called myelin, which is a special insulation wrapped around them, then effectively the ions, these sodium and potassium spikes, only occur at the junctions between the cells that make the myelin, and they're quite a long way apart, and this means that the transmission occurs much more rapidly. And this can occur in a very big neuron at about 120 meters per second. So in a cat, for example, there are quite large neurons that convey sensation and coordination, and scientists have measured the impulses going up and down those at 120 metres per second, so very rapid transmission.
Fascinating question. Okay, our lines are open for you. We're taking a break, but do call us on 021 446 0567 011 883 0702. Let's go to Amanda in Sandton. Hi.
Hi, good morning. How are you doing?
Fine, thank you. Your question, please.
Yes, this question comes from my son, and he would like to know how long it approximately takes for bees to make a beehive.
Okay.
Oh, hi, Amanda. I don't know is the answer, because I'm not an apiarist, is it? Apiculturist. I'm not sure what the proper term is. I really don't know, and I wouldn't like to say, because I will be guessing, and that would be a bad thing. So I'm going to put my hands up and say I really don't know. It's a great question. You got me on that one. Does anyone who keeps bees know this and can tell me how long they take to build a beehive? And shall we say honeybees for the sake of clarity, rather than bumblebees and all the other kinds? Okay. How long do they take?
Do give us a call if you've got the answer, or send us an email. Let's go to Doug in Krugersdorp. Hi.
Hi, good morning. I would like to ask the naked scientist how it came about that a circle was divided into 360 degrees. Why not 400? Why not 200? Why not 100?
Do you know, Doug, I really don't know. There's two in a row that I can't help you with. Obviously, it's got mathematical origins. But again, I'm not going to make something up. I really don't know why they went for 360. I suspect it's something to do with the maths of the right angle and the fact that they've got 90 degrees in a right angle. So four of those makes a circle. But obviously that's one thing begetting the other, and it doesn't really answer the question. So a mathematician, please, can you help?
Yes.
In fact, I have to acknowledge I got a very nice answer from someone in California who listens to Talk Radio 702 and the podcast of this show. And he was referring to our answer to division by zero. And I'd suggested that there were potentially an infinite number of solutions to dividing a number by zero, because I said, well, you can put millions of zeros in. And actually he said, I absolutely have to correct that and say that the correct answer is to say it's undefined. You're not allowed to say that. You have to say it's undefined. Because otherwise you can use it to prove that that other things are true when they're not. So thank you very much to that person. So it's undefined. When you divide something by zero, it is not infinity, it is undefined.
Okay, Doug, thank you very much. Let's see if somebody else can give us more details via email or SMS. We'd like that. Is it Wimpy in Springs?
Hi.
Hello.
Hi. The question I want to ask is about relativity theory, and there was an experiment done with atomic clocks. One went right on a plane.
Oh, you're breaking terribly, Wimpy. I'm putting you back on hold, Mava. If you can help us with that line, you're breaking and we can't hear what you're saying. In the meantime, let's go to Sipho in Cape Town.
Hi. I was going to ask those guys who swallow live ants and insects on fear factor, if they swallow them alive, what happens to them? Do they die? Does the body have some...
What happens to the insects that have been swallowed?
Yes, and the ants, do they die? How long they die if they do die?
Okay, fear factor.
So who are these people eating insects, really?
There's a program called Fear Factor. I think it's a bit like, is it a bit like Survive? I don't know. Let me not, people are very sensitive about these programs. You've got to get it right. So it's called Fear Factor, and you must do shocking things to survive and show that you don't have any fear. And apparently they swallow insects.
Oh, lovely. Well, the answer is that the insect is not going to last very long, because the bolus of food, when you swallow it, gets propelled down your esophagus in seconds and is in your stomach within seconds, and the stomach has acid capable of eating its way through metal in there. I mean, the pH of stomach acid is about 1 to 1.5, so it's really, really low pH, very, very degradative, and the insect in that condition is going to be starved of access to any air and oxygen, because it's mainly a liquid environment, but the pH is going to be horrendously low, and it will kill the insect very quickly.
I have a tweet here from Dean Paul van Sale, wants to know if there is such a thing as north, south, east and west in space.
Yeah, that's an interesting point, because, of course, when you're out in space, how do you navigate? Because you're in something which is absolutely huge, the universe, within the solar system being within our galaxy, within that universe. So there is no compass that you can use. So what actually you have to do is to navigate by other landmarks. So there are some other stars or distant bodies which you can use as landmarks because they're so far away that relative to you, they're not moving their position very much compared to if you used a planet locally, they're going to be going around the sun and you move a little bit, they move a lot. So the answer is that you use your relative position relative to other things you can see relative to each other and work out where you are. So there is no north, south, east and west, but we still know where we are relative to other objects, relative to the Earth.
Thank you very much, Paul. Let's go to Dave. Dave, you've got an answer for the 360 degrees question.
Yeah, good morning all. To my knowledge, the trade system of the world was based on the Phoenician system. And the Phoenicians, instead of having a base unit of 10, had a base unit of 12. That was where you get 12 inches to the foot, 12 hours in the day, and so on. And if you extrapolate that, then your 360 degrees is a multiple of 12, your 60 minutes is a multiple of 12, and so on. And I don't have a reference for this, but this is just something that I learned many years ago. So I'd like Chris's comment on that.
Any thoughts on that, Chris?
Well, it sounds plausible. What I've done is I have also put a tweet out to all the people who follow at Naked Scientists, and we'll ask the thousands of people on there what they think as well, and hopefully we'll get some answers in. Someone has also disciplined me because I let on that the biscuit that I said was very Moorish at the beginning of the programme, I let on it was a Ritz biscuit, and they've said those are not biscuits, they are crackers. So I'm being disciplined for misappropriation of Ritz into the biscuit family. They are crackers. So anyway, they're crackers. I'm sorry.
Probably have the same impact on your body, but we won't go there. Let's go to Vimpy again in Springs. You had a bad line earlier.
Hi. Hi, my question is about relativity and an experiment done with two atomic clocks. One went for a ride on an aeroplane, and the other one home, and there was a difference in time. And I just wanted to know if that experiment was legitimate or if there would be other factors that would affect those clocks.
Okay, the line was still atrocious there. Have you heard? Yeah.
I've got the question, Wimpy. Thank you. The answer is yes, it's absolutely right, and this is the way that you can demonstrate Isaac Newton, Einstein's theory of special relativity. So what you do is you take a very accurate clock, and there are clocks called atomic clocks, and these use oscillations of cesium atoms, and they keep time to a precision and accuracy of down to about, I think, something daft like 10 decimal places beyond a second. So very, very accurate indeed. And if you synchronize two such clocks and you put one on the Earth's surface and you put the other one on an aeroplane and you fly the aeroplane around the Earth in space, the clock which is aboard the aeroplane is moving very fast relative to the clock left on Earth. And because you can't go faster than light, as you approach the speed of light, then things relative to you have to change in terms of time. So time has to compensate. So as you approach the speed of light, because light for you continues to travel at the same speed, time for people outside your frame has to slow down to keep the maths working. And so the clock on the aeroplane continues to tick at what it thinks is the normal time, but relative to it, the clock on Earth is going to slow down. So when you come back to Earth and you look at the two clocks side by side, you see that the clock on the aeroplane appears to now be ticking ahead of the clock on Earth. And it would be the same if you went on an aeroplane or something and travelled very, very fast into space. Then time would continue to tick for you at the same rate that you experienced it as you always have. But for the people you left behind on Earth when you came back, having travelled at the speed of light, they would have aged enormously because time has slowed down for them relative to you.
Chris and Kalami.
Yes, good morning. I'd like to ask the Naked Scientist, when you have a diesel engine and you regulate the speed of it, you limit the amount of diesel that you inject. You don't restrict the inlet, as opposed to a petrol engine where you restrict the inlet. Now, why does a diesel that runs leaner not burn valves, whereas a petrol engine would burn valves if you run it leaner to make it run slower?
Yeah, it's a good question. I've wondered the same thing myself in the past, Chris. I think that it's just that when you make the petrol engine run lean, there's still plenty of air there. And as a result, it just burns really hot. Whereas with the diesel, if you're not putting much fuel in, then even though there's going to be a certain amount of air blown into the engine by the turbo, or just sucked in if it's normally aspirated, if there's not much fuel there, then the temperature can't get very high, because you're just reducing the amount of fuel that can go in. So yes, it will burn very nicely, but it won't make an enormous amount of heat.
Thank you very much, Chris. And thanks to you, Chris, again. Go have your crackers. We'll speak to you next week.
Thanks, really. Have a good weekend, everybody.
Cheers, bye-bye.
And I'll hopefully come back to you with an answer on the circle question next week.
We look forward to that. And of course, this conversation with the Naked Scientist will be available as a podcast.